Hello and welcome to another edition of WAVY Science Lab. I'm meteorologist Jeremy Wheeler, and we're going to be talking about something very simple, something very easy today that everyone can understand, and that is going to be simple machines. Simple machines. Some people don't really know what that means even, but basically simple machines are about six different machines that have been developed over the years to help humans to make things more efficient, to make life easier. So simple machines, this includes the wedge, the inclined plane, the lever, the pulley, the screw, and the wheel and axle. So yes, I'm looking at my notes, but I've got them all here, all separated and ready to go. And so we're going to talk about them one by one and give some examples and talk about how they are, interact with our lives. So let's get right into it and talk about it. And that is the wrong button. There is the right one. So simple machines, simple machines, simple machines, simple machines. And so simple machines, simple tools developed. We use them daily, believe it or not, especially if you work with tools. I use them quite a bit. But even if you don't, I mean, there's a lot of examples of simple machines. So simple tools that do work by magnifying, transferring, or changing direction of a force. So basically, it's it's transferring things. So it makes it easier, right? The energy, it changes it so that our workload is easier for us. Developed over many years. I mean, this was, we go way, way back. We're talking thousands of years of use of these things in development. So general history, ancient times, simple tools. The Egyptians, the Mesopotamians used levers, wheels, pulleys. This is documented. There's historical evidence of this. And Archimedes first studied mechanical advantage, 3rd century BC, right? And Archimedes, we watched the last Indiana Jones movie, and he was in it with the Antique Theater and the little gizmo with the gears in it that he developed. Now, that's actually a real thing. No, it's not magical that I know of, but I actually saw a segment on that History Channel, so that's pretty neat. But anyway, that is not a simple machine. That's just I love movies, so yeah, I'm sorry about that. Okay, so let's talk about it. But yeah, Archimedes first studied the mechanical advantage of it in third century. Then Galileo in the Renaissance explored a complete theory of simple machines. Now the wedge, the first example. So a tool that has at least one inclined edge used to split an object or hold it together, like a vise perhaps. Oldest tool, most likely, 200,000 years ago, rocks were sharpened, used to cut animal hide. Neanderthals, cavemen using these objects, these tools, and older humans to do work, right? To make things easier. The wedge changes the direction of the force, right? You've got a wedge, comes in and it splits. When I do Tai Chi, it's actually a shingi. There's a move that you can actually use. We called splitting. And so it's actually splitting the force of the person. So it's kind of neat. Anyway, so here's the first example, a very simple knife, right? A steak knife, it goes in there and it cuts, whatever you're working on, usually a nice steak, perhaps. If you're vegan, it can even cut vegetables. Hey, it does everything. So yeah, simple machine knife, and that's the first one. Razor, right? I shaved this morning, looks pretty good. And yeah, so you shave, and that wedge literally takes the whiskers and cuts them. And then of course the nail clippers, that's a wedge and a lever, which we'll talk about. But the wedge, the clipper part, is what clips those nails, and that helps us out and makes life much better, because without that, the long nails, forget it for me. But anyway, simple machines of saws. These are several examples. You got a wood saw there, a simple wood saw, a bow saw. That's used for trees, tree trimming a lot of times. And then hacksaw is used a lot of times for pipes, or very fine objects. I've used all of these, of course, and so they all do different things, different tasks. And then nails, believe it or not, a nail is a wedge. It's not perhaps a flat object. It's a point, but still that point goes in, and then it separates the wood, and then the wood splits apart, or at least makes a small enough gap that it goes into the wood. And so that is the example that I have up to that point. Now I want to show you something. We're going to take a look at something. This is going to be very cool, right? All right. So we're gonna or maybe run this a couple times. I don't know, but this is a wedge, and here we go. It's me, and there you go. All right, that's awesome. let's take a look. Let's rewind that again. Okay, let's take it back there. All right, so there and so the wedge chops the wood and bam. Now, use your eye protection if you ever do this, right? Because you have objects flying apart at high speeds, and so I'm wearing eye protection there. Might not look like it, but I am. And yeah, so so I love sound effects. So yeah, so yeah. The wedge, great example there of using a wedge to lumberjacks, people splitting wood, firewood, what have you. That one, I'll admit, it was a little old piece of wood, so it was pretty easy to chop that one. But hey, it looked cool, right? It looked cool. All right, so that is the wedge. Let's talk about the next one now. And I just happened to run that again. But no, let's take a look at the next one. And so now we've got the inclined plane, and the inclined plane, no moving parts. And, we've got, it makes it easier to lift heavy objects. Ramp trades off work for distance. So it can also hold objects like a door stop. There's a good example, right? I've got a simple door stop, holds the door, and it's just an inclined plane. It's very simple object, one of the most simple. There's a slide, right? It does, I think, what you call negative work, where you're actually sliding down. Gravity is working for you. So I think if you were going up, that'd be positive work, down, negative work, I think. I don't want to get too much into that. I mean, it's just, hey, it's fun. It's a slide. I don't want to think about it. But here's stairs, right? This helps out people. If you were to climb a ladder versus stairs, you notice the stairs make it a lot easier, especially if there's not a steep slope. And so carrying objects up this, makes a big difference. And so, a ramp makes it much, much easier. Those, physically handicapped use the ramps to get up, because it's hard to go up those steps for some folks. And so, this is a great example of a way to transfer the workload, right? You want to lift a heavy object up a certain distance. Well, if you were to just push it along that long ramp, it gets the workload gets stretched out. It's easier to do that, right? If you got pounds and pounds of stuff, you take a dolly up a ramp, and that's what we do at the station, and then it's easier to do. And, or you can go no tool. Lifting or stairs, which helps, but a ramp is, it stretches out over a very long distance. And we even have, ramps that do work for us using vehicles, right? There's a bunch of exit ramps and entrance ramps. And so this, makes it a lot easier. If a car was going to go straight up that distance, think about that. Maybe it's 15, 20 feet. But yeah, we stretch it out over a long distance. All right, we're going to come back with some more examples here in just a little bit. So stay tuned. We are back, and we had a couple of cool examples of simple machines in that first round there. So now we're going to take a look at another. Oh, wait, well, this just happened to be back up there again. Sorry, I'm having too much fun with that. All right, let's take a look at the next one. So here's the simple tools. This is a lever, and the lever is a rigid bar rod pivots around a fixed point, a fulcrum, to move or pry a load. Likely the oldest simple machine. That's undocumented. They're not 100% sure, but animals and humans use bones and sticks. So those are some examples, ancient history at how we used a machine that just developed. And, the inclined plane, maybe they used that as well, but I don't know. Maybe they've made some old time ramps, but it has 3 classes. So this is a little bit different. Now here's a simple example. This is a pry bar. And I use many of these. I worked construction and labor for a while, so this is a real good example of you got the nail in there, and so you just use the lever and pry it up. And I've done that many a time. And then here's a lever. This is a door lever, right? You press down on it, it opens the door. It does have another simple machine in there because it's got a pivot off a point, but we'll talk about that a little bit later. So here's the 3 classes of levers, and so the first class. You got an effort, right? The work. You've got the load, which is the weight, and the fulcrum, the pivot point. So the first class example there is some scissors. You got the fulcrum in the middle. You got the effort on the side, and then on the other side, you've got the load, right? And so that does the work for you. It also has a wedge, so it's splitting. But this is a good example of a lever. Second class lever. You've got the fulcrum on one side, the load in the middle, the effort on the right side or the far side. And so the wheelbarrow, great example there. And so, you lift up the effort and you're hauling that load. It makes it easier because of the wheel, but it is a lever, kind of a complicated lever, I guess, best way to put it. Third class lever is one like a shovel where you've got the fulcrum on one side, and then the effort's in the middle and the load is on the other side. So, right, because the shovel pivots around that point, the handle point, and so that is your fulcrum technically. And so that's a great example of a third class lever. So there's some scissors. Right? We got a simple pair of scissors. Use those all the time, and do a good job at cutting paper. Wrapping gifts. You use those scissors, and so right, you've got the wedge, but is the wedge is the sharp part, but then you've got the lever and the fulcrum right there in the middle, that little screw in the middle. And then here's a dolly. And so if I'm hauling that weight, that was a big piece of wood, and if I'm hauling that, then you've got the fulcrum at the wheel, and then of course the effort is the handle there and hauling it. And then there's this is kind of a wheelbarrow, kind of more of a hauler. It does a pretty good job at hauling some leaves and things like that. So again, it's a lever. It is. And it does use the wheel on the bottom. Yes. Here's a very simple lever, a bottle opener, right? Can't open some bottles without it. And so that's a great example of a lever right there. And there you go. All right. So we've got a couple of pieces of tools under our belt. We've had 3 so far. This is now going to the 4th one. And so there's the wheel and axle. A round wheel attaches to a straight axle. And a lot of us use these all the time. I mean, we're getting around in vehicles, all right? And so those use the wheel and axle all the time. These parts rotate, one or both, to reduce friction between the weight and the ground. Sometimes the wheel moves with the bar, kind of depending on what you're doing, and then or the axle rather. But a lot of times it goes around that axle. Sometimes it's to the point that they use ball bearings, which have grease and create it help with friction. And especially for large machines, they use that, like wash machines. There's bearings inside of those. So the history, goes back about 5,000 years. It first appeared in Poland, according to the article that I got this from, and independently invented by the Chinese soon after. That's interesting that, that maybe they'd heard about it and redeveloped it. I don't know that it worked, but interesting that it was about that same time, about 5,000 years ago. It changed everything because before that point, they used logs, and what they did was, they put the logs down and they would roll the heavy objects over it. And, building the pyramids, there was a theory that they used some of these simple machines. I believe there was block and tackle, but getting ahead of myself. I believe they also used heavy rollers to move those weights, the big stones. And then, others as well in history. So that's kind of neat. But then after that, I mean, everything changed because, it accelerated trade. You had chariots, right? Familiar with that in some of the movies. And so, the wheel and axle really made a big difference for that. So here's one good example of a way that it's very efficient, right? And there's a chair there on the right. And so if I was just going to move that around, it would there'd be friction, right? And so it'd make that screeching noise. I don't want to, but anyway, the one on the left has wheels, and so it's easy to move around, and it makes things just so much better and magical, right? So, and not that anybody has drugged that chair on the floor before. No, we wouldn't do that. But it makes it a lot easier just having those wheels on the bottom. All right, and then there's some more examples here. Of course, a bike tire. If you got the wheel and axle on the back, that does have bearings, I believe. But you do also lubricate the axle and especially the chain, but maybe not the axle so much. But yes, it does have bearings, and so that is a bike, and we get around on those. It's very helpful for kids who want to get around just to have fun and play, but also going to places. They can't drive yet. A lot of them younger kids, and so gets them from point A to point B and very efficiently. And then, of course, we're all getting around on these. This is the simple machine, the wheel and axle of the car tire or the SUV tire. And so these, the axles are a lot more complicated because there's also something called differentials, because when a car is turning, one tire will spin faster than the other. And I saw a really cool video on it on X a while back explaining how it worked and how it was developed, and it was very complicated. It was simple in a way, but if you look at the whole structure, it's complicated. So there's a simple axle, and then a little more complicated with the trucks and SUVs and cars, but still, it does use a simple machine. All these use simple machines to get around, and we all use them to get around, and it helps quite a bit. And then we did the podcast on pressure a while back, and how the tire, it has to be inflated, of course, because that helps out. And then the bigger the tire, the more efficient it is. But also, if we went crazy heavy like a monster truck, then it would also be very heavy and maybe hard to get around. So you got to balance out that efficiency. All right, so we just covered a couple more simple machines. We've got a little bit more to go, so stand by and we'll be right back. All right, we're back, and we're in for the third section here now, and talking about two more of those simple tools. And we're going to take a look at the pulley. And I just got to show this again. Sorry, it's so cool. All right, that's enough. That's enough. Jeremy, stop, please, please, please. I mean, we've had enough with the self-righteous hitting of the axe, looking cool thing. It's enough. We're done with it. That's it. Let's move on. All right, let's do that. Okay, so let's take a look at the pulley, the simple machine. So consists of a wheel with a groove rim and a rope. Has a cable around it. Okay, so what does that mean? Well, basically you've got a wheel, which we talked about, wheel and axle, but then it's got the cable around it, or some type of string or cable or something, so that you can lift an object. Usually wheel is mounted on an axle or shaft, so there you go, and it changes the force. A lot of times we use it to pull up instead of down. It gives you a mechanical advantage. Early evidence of use, Mesopotamia, about 3,500 years ago, long time ago. That's interesting, that they were able to develop this stuff very efficiently, many, many years ago, way before the technology really got going. So they most likely used to hoist water from a well, right? That's a very simple example of how they did that. And so again, that's the pulley. Distance to work done is stretched out by the length of the cable. Really also by the size of the wheel. That also makes a difference there. And then you can move multiple wheels as well. But, if you got a long cable, then you can, pull it up, and that stretches out that work. So the efficiency, the mechanical advantage is what it's called. Output force versus the input force. So the output force is basically the load, the weight, and the input force is the force you apply. So, and is it just me, or does it sound like a sandwich? I don't. The pulley. Hey, yo, give me a pulley. I'll order, extra mushroom, or no mushrooms, extra mayo. So yeah, I don't know. But anyway, I'm getting off track. So this is an elevator, and that lifts objects, right? It lifts human beings. So this is it's a great tool because it allows you to go up to many floors now. I mean, you can go up super fast in some of these hotels. Sometimes you're going up 30 floors in a minute, which is amazing if you think about it. But anyway, it's using the pulley system, and it's got that mechanical advantage. It can lift very heavy weight, actually. You can see, 7 people, 10 people, I don't know what the max is, but that will, it does. And then this is one that I have. It uses a complex pulley system. It's a tree saw. So the saw is on one part. So what happens is that black part on there, it will pull it down, and there's a groove that comes in and cuts that branch. And so the beauty of it is you can extend this pole and get up about 15 feet, I think, maybe a little higher than that. And so it'll literally lop off that do you like that? Ow! It'll literally lop off the branch, which is a great tool to use. This is a good example, the James River Bridge, right? It's a steel lift bridge, uses motors, pulleys, cables to lift that bridge up at certain points of the day. Sometimes when it's a little inconvenient, but sometimes, it's got to be done. So to allow ships to get through. So there you go. All right. So here is another example. I've got some weight there, 20 pounds, right? And it's a little heavy. But then if you use the pulley system, it gives you that mechanical advantage. I can do it with one hand, no problem. And so, and it's a great tool. And I use that to work out in my garage. Very efficient. Very cool tool. Okay, so now let's take a look at the last one. This is the screw, an incline plane wrapped around a cylinder. If you think about it that way, we talked about incline plane. Well, this is one wrapped around a cylinder, and it's used to hold things together and make holes like a drill and transfer fluid as well. A fan is a good example of that. And sometimes they even use it to haul water. So it converts rotational force to linear force or vice versa, depending on what you do. So here's a set of screws. It's got threads, right? And the threads, wrap into the wood and hold things together, or drywall, or, metal, or what have you. There's all kinds of different things that it can do there. So a jar and a lid, good example, right? We deal with that every day. You buy a jar of olives, you have a jar of peppers, and so, right, you're putting that lid on and taking it off, and then it holds that lid on. Sometimes it's too tough to get off, and you got to do some tricks. And I've done some tricks. Number one, use a rag. If that doesn't work, you can try and if you sometimes have got special like rubber things you can put on there and grab it, but you want to grab it on tight and pull it off. If that doesn't work, then usually I turn it over and try and get a spoon and try and get that wedge, because the vacuum is usually what's holding it on there. And so I'll do that. All right, so here's a good example of a drill. And there I am. Sorry, I love sound effects. And so there it is. And then it's a quick drill. So I get the screw and put it in, and there you go. It threads it into that hole that I just drilled. And yeah, all right, so that is a good example of the screw and how it works and how we hold things together. And I did accidentally kind of drill that into my workbench, but it was fine because there's some holes in that thing. So anyway, and so we use these tools all the time. Wheelbarrow. Some of these are complicated machines because it's got different parts of simple machines: a lever and a wheel and axle for the wheelbarrow. The same for the dolly. And then, all kinds of things. The bike has a wheel and axle. It's got, the levers. The pedals could be levers. You've got, the handlebars, which could technically be levers, and on a wheel and axle, and all kinds of things. And then maybe even a pulley because of the chain. So, very interesting to just know, how these things kind of apply to our lives and help our lives. Lawnmower, right? The blade has a wedge. It cuts things. And then you've got the wheels on the wheel and axle. Sometimes you pull down the mower and kind of push it so it turns easier. So the handlebars are levers, and just all kinds of stuff in there. So again, that's complicated machines made up of simple machines. All right, so the final thing here, environmental tip of the day: use rainwater. Great way to help save the planet, right? Rain barrels collect the water from downspouts. You can actually hook up a rain barrel to your downspout. I had a relative that did that, and then you can use the water later time. They even hooked up a hose on the bottom. It was very nice to water the lawn, water the garden. All right, so thank you very much, everybody. I hope you learned something today. We had simple machines, and it was a very simple one, but it was fun, and we saw some cool things, especially me chopping that wood. Wasn't that really cool? All right, everybody have a good day.